All right, good afternoon, Algebra. So what we're going to be doing today is we are just going to be doing a little mix-up of all kinds of different factoring of polynomials, a little bit of everything that we've been doing since we started factoring. In this first one, we have 4 terms, so we know we're going to be grouping, so I'm going to go ahead and start with that. And I'm going to group that. And my like term in my first group is going to be x squared, because I can pull that out of x cubed and negative 5x squared. X squared times x would give me x cubed. X squared times negative 5 would give me negative 5x squared. And I'm going to pull this out as a negative 1 right here because they don't have anything in common other than 1. But I'm going to pull it out as a negative 1 because what's going to happen is when I pull out that negative 1, negative 1 times x would give me negative x, which is what I need. And then negative 1 times negative 5 would give me that positive 5. But notice that makes it to where my parentheses are still the same. Okay? Then I'm going to regroup. X squared minus 1 times x minus 5. And if you're looking at that and you're saying, man, something else needs to be done, you're right. Right here, this is a difference of squares. X squared is a perfect square, negative 1 or minus, it's a difference, and then 1 is a perfect square. So this is one of those where you have those two middle terms cancel out. So you set it up where it's a plus minus. You split up the first square, which is x and x, and then plus 1 minus 1. And that is this one factored out completely. Okay? And then you'd go back, x times x is x squared. X times negative 1 is negative 1x plus 1x would cancel out. And then that would be negative 1. And then x squared times x is x cubed. X squared times negative 5 is negative 5x squared. Negative 1 times x is negative x. And then negative 1 times negative 5 is positive 5. So it works. Okay. On the next one, this is just a regular trinomial. Even though it has that x to the 4th, that's still a perfect square. It's x squared times x squared. So I'm going to set up my parentheses. It's a minus minus. So I know that my parentheses have to be a plus minus. I'm going to split that x fourth to x squared, x squared. Then I need two factors of 15 that when I subtract them, I get 2. And so 1 and 15 don't work. 3 and 5 work. So the 5 has to go with the negative because this was a negative 2 or a minus 2x. And then this would be plus 3. X squared times x squared is going to give you x to the 4th. X squared times negative 5 is negative 5x squared. Plus 3x squared would give you that negative 2x squared. And then 3 times negative 5 would give you negative 15. So it works. For my next one, x to the 4th minus 13x squared plus 40. It's a minus plus. So when it's a minus plus, you know that they have to be a negative negative because the last terms have to multiply to make a positive. So I'm going to split that x to the 4th into its square root, which is x squared, x squared. Then I need two factors of 40 that equal 13 when you add them. So 1 and 40, no. 2 and 20, no. 4 and 10, no. 5 and 8, yes. 5 plus 8 is 13. Doesn't matter which order I put them in because they're both negatives. X squared times x squared would give you x to the 4th. X squared times negative 8 is negative 8x squared. Minus 5x squared would give you negative 13x squared. Negative 5 times negative 8 is positive 40, so that works out. Okay? For the next one, I don't have any numbers in common, but notice I have x's, so I can pull that x squared out. So I'm going to pull x squared out. X squared times x to the 4th would give me x to the 6th. X squared times negative 4 would give me negative 4x squared. And when I see that, it's just like that one we saw in the first one. This is a difference of squares. X fourth is a perfect square. A difference because it's minus, and 4 is a perfect squared. So I would have x squared times, one's going to be a plus, one's going to be a minus. The square root of x to the fourth is x squared, and the square root of 4 is 2. And that would be your answer completely factored out. And I can double check it. X squared times x squared is x to the fourth. X squared times negative 2 is negative 2x squared plus 2x squared cancels out. 2 times negative 2 is negative 4. X squared times x to the fourth is x to the sixth. X squared times negative 4 is negative 4x squared. So that one works. Okay, you want to make sure that everything is factored. Make sure that whenever you factor it out, there's not any more factoring that you could possibly do. You have to factor it all the way completely out. Even though this is a perfect square and this is a difference, 2 is not a perfect square, so I can't factor that any further than I have. Okay? And for the last one we're going to do today, this is another one. This is just a regular trinomial, even though it has that x to the fourth. So I'm going to start with my parentheses for my two binomials. It's a positive positive, so I know I'm going to have plus plus in my parentheses. The square root of x to the fourth is x squared, so I'm going to split that up. And then I need two factors of 45 that make 14. 1 and 45, no. 3 and 15, no. 5 and 9, yes. And it doesn't matter which order I put it in because they both are positives. X squared times x squared is x to the fourth. X squared times 9 is 9x squared plus 5x squared is 14x squared. 9 times 5 is 45. And so that works. Tomorrow we're going to be doing some more and just looking at different kind of factoring, making sure that we're going all the way with the factoring, that we're starting by getting rid of that GCF, making sure that we factor completely, make sure there's nothing left in there. And that is what we're going to be doing tomorrow for our last lesson of the week. Remember, we're only doing Tuesday, Wednesday, Thursday. Have a great afternoon, and I'll see y'all tomorrow.